Hello everybody, and again welcome to your maths learning. Okay, so we're going to start with a little rewind of what we've been doing for the last 2 days. Now we've been focusing on improper fractions. Okay, so I just want you to have a look at this. Okay, we're going to rewind, and I simply just want you to have a think. How many different ways could you describe what that diagram shows there? Okay, so just have a pause, rewind all of your learning. How many different ways could you describe what you can see there? So once you've had a go at that, I want you to come on back, and hopefully you've managed to rewind lots of STEM sentences or things that we've done over the last few days. So hopefully you've had a little look at that. Okay, so the first thing that I probably would have gone for is I can see 3 holes. Can you see that? 1, 2, 3 holes. And 1, 2, 3, 4, 5, 6, 7, 8. 5 eighths. So that's one way that I might see that. 3 holes and 5 eighths. Okay, you could write that in words. Or you could have written it like that. Okay, I might see it like that. How else might I see this? Now I know that I could simply do an improper fraction, which is, what's an improper fraction? When your numerator is greater than your denominator. So it's going to be more than so many holes, more than one hole. So 1, 2, so I know that's 8. So then using my times tables, 16, 24, 25, 26, 27, 28, 29. So I've got 29 eighths. 29 eighths. You might be able to say it as an improper fraction. Okay. Any other ways? I would be very interested to see how else you may have described that diagram. These are the main 2 ways that you may have recorded this. You might have got rid of the words there and simply done. That means the same as that. So there's 3 different ways you could have got. So well done if you got any of those ways, just like me. Okay, so let's rewind then to the last 2 days of our learning. So here is my improper fraction, because look, my numerator is greater than my denominator. Okay, and I just want you not to answer it yet. I just want you to explain the steps that you would have to do to convert that improper fraction into a mixed number. So have a little rewind, go back to your definitions in your books. Improper fraction is your numerator is greater than your denominator. Mixed number is what? Have a little think, can you remember? Have a rewind back. Okay, so I want you just to think, what are the steps that I would have to do to turn this fraction into a mixed number? So I'm hoping that you've remembered some of those key sort of STEM questions that we have been using. The first thing I would ask myself is I need to find out how many parts make my whole. Okay, because then if I know how many parts make my whole, I am then going to be able to see how many of those wholes I can make. Ooh, sorry, I've got something in the way, so I can't make that any smaller. Okay, so the first thing, find out how many parts make my whole. Okay, now my next part is going to be how many lots of can I make, not from, with my numerator. So how many lots of can I make with my numerator? So that is simply the same as, so I'm going to put equal to, how many wholes can you build or make? Build's a nice way, because how many of those can I put together? So you might want to do this physically if you're not quite sure. You could actually create these and build them. Okay, so how many wholes can I build? And then my next question is then going to be, so find out how many parts make my whole. Then I need to think how many lots of can I make with my numerator, or how many wholes can I build? And then I need to think how many parts will I have left? How many parts? So rather than parts, you can be more specific here. How many eighths? Oh, helps if Miss Tyson can spell them. Got my H. How many eighths will I have left? Okay, so those are the steps that I'm hoping that you reflected on. So let's have a go. So now you know the steps that you need, and we've reran the steps to turn this improper fraction into a mixed number. Can you have a go? Can you rewind for me, and can you tell me what this number, this fraction here, would be as a mixed number? And I want you to show me you're working out. Okay, so there's the improper fraction that I'm going to start off with. So how many parts make my whole? So 8 parts make the whole. I have 29 of them. Okay, so I'm going to find out how many groups of 8, so how many wholes can I make? So the number sentence that I'm going to do there is 29 divided by 8. Okay, because I'm going to see how many groups of 8 I can make. So I'm going to use my times table here to help me. So 8, 16, 24, 32. Now 32 is too many because I've only got 29. So the closest one I can find is 24, which is how many lots? I can make 3 lots. And how many am I going to have left over? So 3 lots of 8 will give me 24, but I've got 29. So how many will I have left over? I will have 5 left over. Okay, so 29 divided by 8 equals 3, remainder 5. So here you can see how your division skills are going to help you. Okay, but is that a mixed number? No. So I've taken 3 lots to make 3 wholes, haven't I? I've taken 3 lots of 8 eighths. So here you've almost got 8 eighths, 8, 8 and 8 eighths. Yeah. So then I add them together. That's 24 eighths. But how many do I have left? How many do I have left? I've got 5 left. So remember, those are 5. Are those 5 wholes? No, I've got 5 parts left. So I've got 5 parts left, and I know that each of those parts, the parts, how many parts make my whole? 8. So I have 5 eighths left because I've only got 5. I cannot make another whole. Okay, because I've only got 5 eighths left. Wonderful. So 29 eighths as a mixed number is 3 and 5 eighths. Okay, so well done to you if you got that right and remembered those really important key steps. Brilliant. So today, what we're going to do, we're almost going to tip our learning on its head. Okay, so we've been doing 2 whole days on thinking about mixed improper fractions into mixed numbers. So now today we're going to switch our learning upside down and back to front, and we're now going to be focusing on converting mixed numbers back into improper fractions. So it's almost like a reverse of what we've been doing. So I'm hoping you've already got some ideas coming into your heads. Why? So that we can begin to compare and order mixed number fractions. So we can start to think about the largest, the smallest, and begin to order them. So this is starting to then develop into a new skill that we're going to be moving on to soon. Okay, so today we're going to be doing mixed numbers into improper fractions. So pause, explaining glasses on. So what is a mixed number? Now, we have already spoken about this morning, so I'm hoping that you are going to be able to just ping straight away. Tell me what a mixed number is. If you cannot, you can rewind back to Monday's learning when we did the definitions in our books. If you didn't write that definition, then maybe just rewind a little bit because we've just spoken about it. So hopefully you are now in your head telling me what a mixed number is. And I'm hoping that you are saying that a mixed number is a number that's made up of wholes, and fractions. Okay, so that's why it's a mix, because you've got fractions and you've got wholes. Okay, it's not just fractions, it's not just wholes, it's a bit of both. Okay, so what I would like you to do is to use that knowledge now and just simply tell me which of those are or is an example of a mixed number. Okay, which of those are a mixed number and how do you know? Nice and easy peasy. An extra prove it if you think, yep, I've smashed this. How else might you be able to show, or is there any that you could turn into a mixed number? So once you found the ones that are a mixed number, is there any others that you could have a go at turning into a mixed number? Start to explore it. Brilliant. So I'm hoping you've had a little reflect on that now. So let me just get my shape. There we go. Okay, so a mixed number is made up of wholes and fractions. So I'm going to have a look at this one. Now, this one, I've got a numerator and a denominator. So it says that a mixed number is wholes and fractions. I can only really see a fraction there. I can't see any wholes in that number. Okay, so this one here, I've got 4 and 5 halves. Oops. Oh. Don't know what I've done there. Get rid of that. There we go. Okay, so I can see here I've got a number, a whole, and I've got a fraction. Okay, even though that fraction actually, you are probably noticing, has still got something a little bit wrong with that one. It's still a mixed number, so someone's only sort of done their half a job. This one here, I can just see a whole number. I can't see a fraction as well. And this one here, I can see a number and a fraction. Okay, so let me think then, are there any others that I think could be a mixed number? So I think this one here isn't quite finished because actually, look here, I've got 5 halves. I think I can make some more wholes there, don't you? So let's just look at what they have done. So let's remember, when we're doing our improper fractions, it's how many wholes can you make? 2 parts make my whole. So if I've got 5, I can actually make 2 more wholes there, can't I? Because I can make 2 more wholes there because I've got 5 halves. So if you've got 5 halves, those 2 will come together to make a 1. Those 2 will come together to make a whole. And then you'll have 1 left over. So now I've not got 4 wholes now. I've got 6 wholes. Okay. And this one here, I've got 8 halves. So let's have a look. How many parts make my whole? 2. I'm just going to put my pen on. 2 parts make my whole. So how many lots of 2 can I make? 2, 4, 6, 8. I can make 1, 2, 3. 4. So if I was doing that, it would also be the same as 4. But is that going to be a mixed number? Because I haven't got numbers and fractions. I haven't got wholes and fractions. That's just a whole. Okay, so is that a mixed number? No. So when I convert it, it's an improper fraction. If I convert it, it is just a whole number, just like 5. Whereas these are mixed numbers because I've got wholes and I have got fractions as well. Wonderful. So let's get on with today's. Ooh, let me just get rid of my pen. How do I do that? There we go. So now we're going to be focusing then on showing mixed numbers, converting mixed numbers into improper fractions. So mixed numbers are wholes and fractions. Improper fractions are when they have got a larger numerator that's greater than the denominator. Okay, so have a look here. There is my mixed number. So I just want you to have a little go using your knowledge that we've used for the last 2 days to convert from improper fractions to mixed numbers, how do you think we're now going to turn this mixed number back into an improper fraction? So what are the steps to convert? What are the steps going to be to convert this mixed number? So if you want to pause it and see if you can think of those steps that you're going to have to do to convert from a mixed number to an improper fraction. So hopefully, if you're with me now, you will have had a go at this. Okay, now even if you're not sure, that's the whole point of this. We're just doing a bit of a discover. I want you to have a little bit of an explore and try and make your links between your learning. I would like you to have a go. So make sure if you haven't had a go, make sure you still pause it now so you can have a go before I tell you. Okay, so the first thing I'm going to do is I'm going to write that mixed number on my board. Okay, now this mixed number is actually telling me I've got 4 wholes and 2 fifths. Okay, now which part of this number is going to tell me how many parts make up my whole? Which part of this mixed number tells me how many parts make up my whole? Now I'm going to rewind this learning all the way back to last week because we know that the denominator tells me how many parts make up my whole. So here, 5 parts make up my whole. Okay, so 5 parts make up my whole. That's the first thing I need to think of. How many parts make up my whole? So that's very similar. That's the same as when we were converting the other way around. Okay, I still need to know that important information. Now, my mixed number, I've got 4 wholes and 2 fifths. So what's the next thing I need to do is to think, right, so what does this 4 represent? What fraction is 4 wholes? I already know that my denominator is going to be 5, don't I? Because that's how many parts make up my whole. But how many fifths will I have to make 4 wholes? So how many fifths will I need to make 4 wholes? So I could draw this. So there's my 4 wholes. Just bend that a little bit. Could draw this. It's going to take me a little bit longer, but let's go with it. And we're just going to turn this into fifths. 1, 2, 3, 4, 5. So mine aren't perfectly equal, but I'm having a good try. There's 5. Fifths are quite tricky to draw, I'm sure you found. 1. There we go. So here's my 4 wholes. 1, 2, 3, 4. So how many fifths will I need to make those 4 wholes? So each of them is split into fifths. So I know we've got 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know that to make 4 wholes, I need 20 fifths. Okay, can you see that? Now I'm hoping that you are already starting to see a pattern here. What would be a quicker way for me to work this out? Can you see a quicker way to work this out? Do you want to have a pause and just think, is there a quicker way rather than drawing all of my wholes that I could have worked that out using this bit of information here? Okay, so the information that I know already is that to make a whole, you need to have the same number in the numerator and the denominator. So if my whole has 5 equal parts, to make a whole, I will need 5 of them. So 5 lots equals 1 whole. But here I've got 4 wholes. So what could I simply do to these numbers to get me the answer? So I know that 5 lots make 1 whole. So I know that I just need to do 5 times by 4, because I've got 4 lots, will give me 20 lots. Okay, are you seeing that relationship there? So 1 lot I know is 5 fifths. So if I've got 4 lots of those, it's going to be 5, 10, 15, 20. Okay, but am I finished? Have I finished converting that fraction, that mixed number, into a fraction? So I thought about how many wholes, how many parts make up my whole? 5 parts make up my whole. How many parts do I have to make 4 wholes, which is 20? So is that it? Am I done? Am I done? Is that my answer? No, because what else do we need to remember? The fraction that we already have. So I already have 2/5. So this is equal to 20/5. Can you see that we've just worked that out? I've already got 2/5. So what am I going to have to do now to get my final improper fraction? I'm going to have to add them together. So 20/5 was the same, is equal to 4 whole ones. I've already got my 2/5, so I simply need to add them together. They're the same denominator, so I simply need to add my numerators together because they're already in fifths. I've got 20/5 already. I'm going to add 2 more fifths. I'm going to have 22/5. So 4 and 2/5 is the same or equivalent or equal to 22/5. Okay, so let's see if your steps were the same as mine. Okay, so here you can see the steps that I wrote down here. So well done to you if you got these steps right. So the first thing I did was how many parts will make a whole? So I use that denominator to help me. How many wholes do I have? Which is 4. So how many parts make those wholes? So if each of my wholes have 5 parts, I've got 4 of them. So I timed them together or I drew it. And then the final step was how many parts do I have altogether? So this is where you have to think about adding on that fraction that's already there. Okay, so the best way to get the hang of this is to get practicing. Okay, so you can see I've given you 2 mixed numbers there. So we've got 6 and 1/3, and we've got 8 and 2/4. Okay, so I'd like to see you following these steps one by one to see what these would be as improper fractions. Okay, so how many parts will make a whole? How many wholes do you have? So how many lots of that are you going to have? And then are there any parts that you need to add on? So think about that fraction at the end, you need to add that on at the end. Okay, so I want you to have a go at those 2 for me. If you need to just remind yourself on the process, just rewind me and just rewatch how I did mine, and then you can then follow those steps to have a go again. Okay, once you've had a go at those, there's a little convince me there. So somebody's had a little go at converting a number. So have a little look. What mistake has been made? And then come on back when you've had a go to see if you were correct. Okay, so hopefully you've had a little go at that now. So let me just make myself a little bit bigger. Give my board a little wipe. So hopefully you're starting to see that this is almost like a reverse of what we've been doing for the last few days. So instead of dividing, we're now using our timesing skill. So 6 and 1/3. Okay, so the first thing I'm going to focus on is this 6. 6 wholes is what? So if I've got 6 wholes, how many parts make up my whole is my first step. So 3 parts make up my whole. You can't see that, sorry. 3 parts make up 1 whole. Okay, so 1 whole is equal to 3/3. Okay, so if I now have 6 wholes, what is that multiplication that I'm gonna have to do? 3 parts, 3/3 make up 1 whole, but I've got 6 of them. So I'm gonna have to do 6 lots of 3, because imagine, again, draw it if you need to, okay, because that's really gonna help you to count and to check how many parts. So there's my 6 parts, and then I can simply use my 3s to count. So there's 3, 6, 9, 12, 15, 18. So 6 times by 3 is 18 parts. Okay, so 6 wholes is going to be 18 thirds. So remember, we are creating this improper fraction. So the parts that you have are going to be larger than your original starting, because I've got 6 lots of those thirds. Okay, so 6 wholes is equal to 18 thirds. Have I finished? Can I say that they are equal? That is equal to 18 thirds. No, because what have I not done? It's a mixed number, so I've done my whole. What have I not added on? My extra one. So it's going to be 18 thirds plus 1/3, which is then going to give me how many thirds altogether? It's going to give me 19 thirds, which is the improper fraction for 6 and 1/3. Now, if you wanted to be extra careful and check your answer, what you could always do is now turn that improper fraction back into a mixed number, because if it does, you should get 6 and 1/3. Okay, so well done to you for that first one. 6 and 1/3 as an improper fraction is 19 thirds. So 8 and 2/4 then. 8 and 2/4. So again, I'm going to see how many parts make up my whole. 4 parts make up my whole. So 1 whole will be equal to 4 quarters. Okay, I've not got 1 whole. I've got 8 wholes, which is going to be what multiplication am I going to have to do? I've got 8 lots of how many parts, how many quarters. So I'm going to have to do 8 lots of 4, because each whole is going to have 4. So it's almost like 8. That's going to have 4, 4, 4, 4. And you see? 4 quarters. That whole will have 4 quarters. That whole will have 4 quarters. That'll have 4 quarters. That'll have 4 quarters. And that'll have 4 quarters. Okay, so I need to see how many of those quarters is going to make 8. So I'm going to do 8 times by 4, which is 8, 16, 24. Really practicing my times tables here. 8, 16, 24, 32, 40, 48, 1, 2, 3, 4, 5, 6, 56, 60. Oh, what am I doing? 8 times by 4, I don't need that many. 1, 8 times by 2, 8 times 3, 8 times by 4 is 32. So for 8 wholes, I'm going to have 32 quarters. Okay, so that is the first step. So how many parts make up my whole? 4 parts make up my whole. I've got 8 of them, so I'm going to do 8 times by 4, because I've got 8 lots of those 4 parts, which is going to give me 32 quarters. So am I finished with 32 quarters? No, because that is just my whole. I've also got the 2 quarters that are part of that mixed number. So to get my total for my improper fraction, I need to add them together. So I'm going to have 34 quarters. Okay, so my equivalent fraction for 8 and 2/4 is going to be 34 quarters. So well done to you if you got that right. So now I just said the best way to check is to do your improper fraction back into a mixed number to check that you're correct. So let's check this one, shall we? So I'm going to take 34 quarters and we're going to rewind our learning from last week to check if it does get me 8 and 2/4 as a mixed number. Okay, so 34 quarters, if I'm right, it should be 8 and 2/4. Okay, so let's check it. So how many parts make up my whole? 4. So how many lots of 4 can I make? How many wholes can I make with 34? So I'm going to do 34 divided by 4. How many groups of 4 can I make? I'm going to use my 4 times table. 4, 8, 12, 16, 20, 24, 28, 32, 36 is too many. So 32 is what I'm going to go for. So 1, 2, 3, 4, 5, 6, 7, 8. I can make 8 groups. And how many will I have left over? Remainder 32, 33, 34, remainder 2. Okay, so that is telling me I can make 8 wholes and I'm remainder 2 parts, but it's not 2 parts. It's not a whole number, it's 2 quarters. There we go. So well done if you got that right. And also well done if you managed to check your answer using our learning from the last few days. Brilliant. So once you've had a go at those, if you think I've really got the hang of this now, then you can have a little go at the convince me that I've put in the box here. So one child has had a really good try at converting the mixed number with an improper fraction. Okay, but I want you to see what misconception have they got? What mistake have they made? So have a little go at that. Just write convince me in your book and underline it and explain what they've done. And then can you fix their mistake? Okay. If you think, Miss Sanson, I'm not quite ready for that, I just need to keep practicing, so I can get the hang of this method, converting, then you can head on over to your Hegarty Maths. Okay, so I've set you mixed numbers to improper fractions. So it's just a way to generate lots of questions so that you can keep practicing this method. Okay. If you think I need a little bit of a recap, then of course rewind this video and just rewatch how I have done it, and then you can copy my step by step. Remember, you've always got our STEM sentences to refer to, or in the first one you have written the steps, how to go writing the steps that you need to do this. So there's lots of things that you can refer to help you. Okay. And some of you will also have experienced some of this the other way around on the gem game the other day. Okay, so if you need to, draw out your physical representations. Okay, if you're not quite ready to use your times tables yet, you don't really understand this, just simply draw it. Okay, just remember that how many holes have you got, how many parts in each one, and that is a good way that you can still get the answer, even if you're not ready to do your times table method. The quicker method yet, draw it. Okay, wonderful. I cannot wait to see all the great work that you send us on Hegarty. Again, if there's any problems, just drop your teachers a message and we can try and help you out. Have a lovely day and I'll see you all again tomorrow. Goodbye.